Generally, you use group data samples when you have a rather large amount of data, but to avoid taking up a lot of time, I'm not going to use very large amounts of data here. But let me just show you how this works. In this first column, you have class intervals. In other words, you have intervals that represent the range of a set of values. And so, I don't know exactly how to tell you how these intervals are best determined. So I'm just giving you some intervals. So let's say that you have a class interval from 3 to 7, and frequency just means how many there's going to be in there. So there's going to be 4. There's 4 values that fall within the range 3 to 7. And then the range 7 to 11, there's 2 values that fall within that range. And then the range 11 to 15, there's 1 value. And then the range 15 to 19 is 3 values. And if you add these numbers up, that tells you the total number of values you have. So we know that n is 10. Now, since we don't know what's in the class interval, we just use the midpoint of the class interval. So the way to find the midpoint is just to add the 2 endpoints and divide by 2. So the midpoint of this interval would be 3 plus 7 divided by 2, which is 5. The midpoint of this interval would be 7 plus 11 divided by 2, which is 9. This interval, 11 plus 15 divided by 2 is 13. And then this one, 15 plus 19 divided by 2 is 17. Now, so basically what we're going to assume, since we don't actually know what values are in this interval, we're just going to assume that we have 4 of these values, 4 5s. And so what we do is we take that x value and we multiply it by its frequency to get the sum of those 4 values. So 4 5s would give me 20. And then here I have 2, and these would be 9s, so 2 9s would be 18. We have 1 13 here, so that would be 13. And here we have 3 17s, and that would be 51. And then what we're going to do is we're going to add all of these up and get 102. And so we're adding the each data value times its we're taking each data value times its frequency, and then we're summing them. So each one of these is the data value times the frequency, and then this tells us we're going to sum those. So when we add all these up, we get 102. Okay? So now all we have to do next is we just have to divide that by n. So this is the formula for calculating the mean for group data, and you can see basically you take the sum of each data value times its frequency and then divide by n. So in our previous example, when I did that, remember I got 102 for the sum, and then I divided by the total number of values n, which is 10. So 102 divided by 10 gave me 10.2. So that's how I find the mean using group data. Okay, now I'll show you another one, and sometimes we can use decimals to avoid confusion at the endpoints. So suppose we have the following data and want to enter them into this table down here. So I'm going to just give you 3 class intervals, 2.5 to 6.5, 6.5 to 10.5, 10.5 to 14.5. And one reason we might do it like this is so that, if I had a number like 6 or 7, I would know that the 6 would go here and the 7 would go here. So now let's take a look. How many values do I have from 2.5 to 6.5? So I have 4, 3, 3, 4, and 6. How many values do I have in the range 6.5 to 10.5? I have 2 values, 7 and 8. And then how many values from 10.5 to 14.5? I have 4 values, 11, 11, 12, and 13. Now, so the frequency is I have 4 values in here, I have 2 values in here, and I have 4 values in here. And then if you add these two together, 2.5 plus 6.5, that gives me 9. And then we divide it by 2 to get the average of that interval. That's 4.5. And so we assume we have 4 values of 4.5, which adds up to 18. 4 times 4.5 is 18. And then here, 6.5 plus 10.5 is 17. Divided by 2, and I get 8.5. So this is like having 2 values of 8.5, which adds up to 17. And then 10.5 to 14.5 is 25. Divided by 2 is 12.5. So this is like having 4 values of 12.5, which is 50. Now, then of course we add these together, 18 plus 17 plus 50, and get 85. And then finally I divide that by 10 to get a mean of 8.5. Now you might be surprised how close the mean is to the actual mean. Now on this one I could have easily just added these together and got the actual mean. So if I did it correctly, I added these together in my head and divided by 10, and I got a mean of 7.8. Okay, but again, the reason you would do a table like this, you really wouldn't need to do a table like this for only 10 values, but a table like this would be done if maybe you had 1,000 values or 500 values. Then you would use a frequency table like this to calculate the mean. Okay, here's a practice problem, and you can freeze the video here and give this practice problem a go. I calculated the first midpoint for you. So here you would just take 299.5 plus 349.5 and then divide it by 2, and you get 324.5. And then the frequency is 1, so you just take 324.5 times 1, and you'd put 324.5 there. And then here you do the same thing, add these together, divide by 2, put the midpoint there, then multiply that midpoint by 2 and put the result there. And then of course you would add these up, and that would give you the sum of the product of the xi, fi, and then you would add these up to get n. And actually, if I did the math correct, the n will add up to 100. These sums should add up to 57,900, and then when you divide by 100, you get 57.9. Actually, that would be 579 if you divided this by 100. So go ahead and check it, but I believe that's really going to be 579, not 57.9. Okay, now to calculate variance from group data, here's the way you calculate sample variance. You take the difference of the data value minus the mean, square it, but then you have to multiply it by the frequency, and then you add it all up, and you divide by n minus 1 for the sample variance. But for the population variance, you do the same thing, but you divide by n instead of n minus 1. So let's do that simple example we did earlier from up there, where we had just these 4 class intervals. And so here we know the frequencies were given to be 4 here, 2 here, 1 here, and 3 here. And we knew these were the midpoints, 5, 9, 13, and 17. And now, so what I need to do, I have to take the difference between 5 and the mean, 10.2, and square it, then multiply it by the frequency. Because remember, it's like I've got 4 of these 5s. So instead of saying 5 minus 10.2 squared plus 5 minus 10.2 squared plus 5 minus 10.2 squared plus 5 minus 10.2 squared, I can just say 5 minus 10.2 squared, multiply it by 4, and that gives me 108.16. And then for 9, I take 9 minus the mean squared, and I multiply that by 2 because the frequency is 2. And then I take 13 minus the mean squared and multiply that by 1 because I only have one of those. And then I take 17 minus the mean squared and multiply that by the frequency of 3. And then if you add all of these up, then what that does is that sums this product, x minus x bar squared times fi, it gives me 257.6. And in order to calculate the sample variance, remember I have to divide by n minus 1. So since n is 10, n minus 1 would be 9. So divide that by 9, and I get 28.62. And then finally, to get the sample standard deviation, take the square root of that, and the sample standard deviation is 5.35. And then the only difference in getting the population variance, instead of dividing that by 9, I would divide it by 10 and get 25.76, and then take the square root of that to get the population standard deviation, which is 5.08. So, interpreting the standard deviation, the more variation that you have in your data, the greater the standard deviation. The larger the standard deviation, the more spread in the shape of the histogram. That's just a graph that represents how the data is spread around the mean, so I won't go into that. Now, standard deviation is used for quality control in business and industry, and if there is too much variation in the manufacturing of a certain product, we say the process is out of control and adjustments to the machinery must be made to ensure more uniformity in the production process. This is just one more example, and I won't spend a lot of time on it, but you should know how to calculate it by now. But the first thing I need to do if I'm going to calculate the standard deviation is calculate the mean. So to calculate the mean, I just find the midpoint of each of these intervals, which I wrote right here in this column. It doesn't matter whether you write the midpoint of the frequency column first, but these are the midpoints, and then these are the frequencies. So multiply these midpoints by the frequencies to get these numbers, and then you add these numbers up, and then you divide these numbers by n, and remember you get n by just adding up all the values in the frequency column. So in this case n would be 30. So add 495, divide 495 by 30 to get 16.5, and that's the mean. And then once you have the mean, you can calculate the variance. So again, same class intervals, same midpoints, same frequencies, but here I have to take each value minus the mean squared and then multiply it by the frequency. So here you take the 8 minus the mean squared, multiply it by the frequency, 13 minus the mean squared, multiply by the frequency, and so forth and so on. And then once you get all of these values, you add them up and you get 1807.5 for the sum. And then remember, you divide this by n minus 1, and since n is 30, you divide this by 29. And so your sample variance is 62.33, and then your sample standard deviation would be the square root of that, which is 7.89. Now I'll leave you with a practice problem here that you can do to find the mean and the standard deviation for this group data here, and the answers are given below. Now I don't cover the next thing that I'm going to show you in this, but I'm going to show you this, and then I'll just leave it for you to look at here. And this is just a way to calculate the median for grouped data. So you can freeze the video and read this if you like. I don't test over this, but you actually can calculate the median when you have grouped data given in class intervals like this. And by the way, this is what a histogram would look like. So you can pause the video and read this if you like. If you need to, you can Google more information on YouTube or something. But again, I'm not going to cover this, but I'll just leave you with this example here to read. And then I'll just wrap things up with this summary sheet here where I give you some data, and then I do some calculations off of this data. So I just calculate everything that we've talked about in this particular section. And that is the end of these videos for my Finite Math course.